Hello, this is a tutorial screencast demonstrating the data-tests YAML file at the root of GitHub Actions. So as a reminder, figure 1 in the manuscript is as so. And the basic pipeline is that after data is collected, you push it to GitHub, and then this sequence of tasks, which are automated by GitHub Actions, take place. So again, we have a rough description of the steps where we install the needed packages, we check for field fix errors, auto fix errors, and an optional checking for warnings. We then update the dashboard components, which then all write to files in the GitHub repository in blue, and then if necessary, alerts are sent. Let's go in and delve into the data-tests YAML file at the heart of this process. So let me first open up another tab with the same repository structure here. And again, you can find a link to this repository, which is open access, in the supplementary materials in our paper. First, let's locate the data-tests YAML file. They're always going to be in the .github folder. Let's click on that. Let's click on that. Great. Now this might seem overwhelming at first, but once you break down the individual components, you'll see that they all correspond directly to that figure 1 from the manuscript. First, what we have here from lines 5 to 21 determine for which files, when changed, do we want to trigger GitHub Actions. Because sometimes maybe if we change a peripheral file that's not so important, we don't necessarily want to run GitHub Actions automation. And in this particular case, we see that it is the contents, for example, of the raw data folder, FFF Excel star. So let's go over here. Raw data, FFF Excel. So anytime a file in this folder gets changed, well then we'll rerun all the GitHub tasks. Here we have an exclamation point that says, okay, don't rerun if the README file is modified, because the README does not changing the README does not correspond to changing the data or the code. So ignore this particular file inside the raw data folder. But here's where it gets more interesting. When any of these script files get changed as well, so remember, this corresponds to adding new data, but these 4 lines correspond to changing an R script. Whenever we update our R script, we want to rerun the entire GitHub Actions process. And those are contained in R scripts CI1, generate reports, generate warnings, and these last 2 files correspond to the dashboard. So let's go back over here. If we go back to the root directory and we go to R scripts, we see we have CI1, 2, 3, 4. Anytime either one of these 4 files have a change that is pushed, GitHub Actions will get triggered. And when GitHub Actions get triggered, you'll see it over here. In the Actions tab, let's take a look. We have previous GitHub Actions runs where changes have taken place, and we see basically a catalog of all the GitHub Actions runs. So we can see here that while we're testing out new code and new data, we've unfortunately got a couple of failures. But when all checks and tests pass, we get a green check mark. But again, the important thing to remember is that anytime we change any of these files here, a GitHub Actions task or job will get run. This will occur in the main branch here. But for example, we can also specify that for a pull request, meaning you haven't quite merged it into the main GitHub branch, you can also specify different sets of files. In this case, we kept it the same. So the thing to remember here, folks, is if you change the data or if you change any of the data scripts, GitHub Actions will run. Great. Next, name, data tests. this is what the job will be named again on that Actions tab. So if we go over here, we see that, yes, that corresponds to data tests. The nice thing about GitHub Actions is that you can have separate files or separate YAML files that correspond to different jobs. So you could have maybe data-tests or maybe another script like data-wrangling. But in our case, we keep things simple and only have one particular name, and that's data-tests. Great. Next up, these two lines says that, okay, for data tests, what operating system are we going to assume when running this job? Now you can get as specific as specifying Windows, Mac, Linux, and all sorts of different versions of all those software, those operating systems. In our case, the complexity of our work isn't that complicated, so we stuck with only the latest version of Windows. This next line here, we don't have to really work with directly, but this basically sets the GitHub Personal Access Token. That is what prevents people who don't have access to this particular repository from making changes via GitHub Actions. So whenever you give a user permission to edit a GitHub repository, they'll be able, this line calls their personal access token and gives them permission to write to this directory. Next, here are some housekeeping steps. First of all, if you want to make GitHub Actions work, you need to import certain libraries. For example, this thing here is the Actions Checkout version 2 library. Now, I've included a link to where this library is. But in the case of our paper, where we use R as sort of the backbone coding language to run our tasks, we use the R lib actions library. So why don't I copy that here, paste that here. Now, we don't have to get into the weeds here. We can just take a lot of these things as given. But we're going to leverage some of these libraries that other people have written in order to use R for our GitHub Actions task. Specifically, we're going to use the setup R action library of tasks, meaning set up R in our blank operating system, which again we assume to be Windows. Next, housekeeping. Install all the package listed in the description file. So here is the name of the particular step. It will run this line of code and then this line of code. And then it'll say go to the shell or execute these two lines of code using R. So first, let's go to the description file. This description file matches the structure of a description file in a R package. But what you need to remember is that for any R package that you use in your GitHub Actions tasks, they have to be specified here, because that way GitHub Actions will know to install these packages. So that is what happens right here. But now let's further break down what this name means. If you go, again, back to the GitHub Actions tab here and click on a particular run, we'll click on that, we see we have an overview of all the different steps in a particular job. And over here, we have install dependencies. And that corresponds to this step right here. Next up, we have check over here. Now, I may be wrong, but I think that this step may not be needed and is used in particular for checking whether or not an R package is valid. So I think this step may not be necessary, but I'm not 100% sure. But here's where it gets interesting. Yes, run R script to generate error reports. Again, we have the name of the job. We give it an ID. It says run this particular R script. So if you have a different R script you would want to use, you would change the name of the file inside source. Again, let's go and take a look at this file. We go over here, SCBI mortality, R scripts. It's going to run this particular file here, which if we take a look at closely, is just our code. So if you have existing R code that to process your data, you can reuse it or repurpose it for GitHub Actions. And this says, okay, use, or it's telling the GitHub Actions to say, run this particular R script over here. And again, that corresponds to, in figure 1 of the manuscript, step 2, generate reports, which will then, if any field fix or autofix errors are found, will write these errors to a CSV file. Next up, we have generate warnings. So again, run another R script to generate the warnings. These next two, from line 73 to line 85, that corresponds to the dashboard elements. In other words, generate the map of reports and generate the daily progress reports. And by running these scripts, so why don't we take a look at them? So by running this script here, generate map of reports, we see again, it's a lot of R code. And by running the script generate daily progress reports, in our case, what's going to happen is that they're going to write images, which then go onto the dashboard repository, the repository dashboard, which in this case is the README file. Now again, this is taken at a point in time where we just started the census and the 2022 mortality census, so we're testing things out. But this would correspond to the figure of the example dashboard in the manuscript. Next up, this here you can basically just take as is, where, okay, we're going to tell GitHub Actions to say, okay, for any new files that have been created, such as, if we go back to the figure, if there was a new CSV file written, or if the dashboard was updated, lines 87 through 95 say, okay, commit and push these new files to the repository. That way they get saved to the repository. And they're going to get saved under a user just called GitHub Actions, kind of a bot. So it'll just do a pull, it'll add the files, it'll commit the files, and then push. Last but not least, recall in the manuscript we said that there are two kinds of errors that you can encounter when running a GitHub Actions job. If there are any bugs in the code, for example, if somehow one of your scripts has a coding error in it, it will return an error message saying, hey, your code did not run. But also recall that we want to receive notifications of data collection errors. Remember, if data collection errors exist, right here. Oh, yes, email a failure alert if any step in this process fails, or if a data collection error exists. In other words, whether or not a field fix errors.csv file got created. And the way we leverage that is using the test that package. And we do that by running the test that package. Running the script test that.r. So let's take a look. This gives us a pointer to say, okay, take a look at the test that, first of all, load the test that library, but then go into the test that folder. Okay. Let's go into the test that folder. And over here, whenever you include an R file over here, it will run those R files, okay, and check whether or not those tests passed. So in particular, this is where it gets interesting. There are errors that require field fixes. So over here, what it's saying is that, okay, if there is a file called requirefieldfixerror.csv, return true. And then it says here, expect false. Okay, so we have a little bit of a double negative here, but basically if there exists a report, meaning there is a field fix error, then what you need to do is, you're expecting false, this will return true, this will raise an alarm. Now, unfortunately, this seems there were many steps in this process to get that alert, but this is because we want to reuse the test that package for our data collection error alert system. We don't want to reinvent the wheel. The test that package, as stated in the manuscript, is used chiefly for checking whether or not, or I should say, doing unit tests on our packages. But in our case, we repurposed it. Don't forget, folks, that if you go to updatingdata.org, we have a bare bones tutorial set up here, which allows you to build a GitHub Actions repository from scratch. So if you feel confident in looking at our repository and you would like to build off of ours, then you can go ahead and clone this repository. But what we did, in fact, was we originally cloned this example over here, where we give you a template repository and we give you some examples that you can work with on your own. This is a quick start tutorial that should take about, for somebody with, let's say, some experience with GitHub and R, it should take about half an hour to complete. Great. Thank you very much, folks, for this tutorial, for listening to this tutorial. And in particular, remember that in .github, workflows, data.data-test.yaml, this is the heart of the GitHub Actions process we illustrated in the paper, in particular in Figure 1. Thank you.